Okay, guys, awesome to see you again. So this week 8, trying something different. Firstly, not recording me physically writing it. I'm going to use a program. So I'll write the problems in on AutoDraw, and we'll see how that looks. Hopefully, you guys. Hopefully, it makes things clearer for you and easier for you. It definitely makes things worse for me, but um, you know, if it's better for you guys, then that's what it's all about. So let's get to the topic of the day. Boom. So today we're going to be looking at a real simple concept, which is called, we're using the practice of doing equal multiplication to make problems simpler. Because we're starting division problems, and believe it or not, a division strategy is equal multiplication. And I'll get into that. I'll get into that next. But just so that you know what's happening, I'll just run over the assignment. It starts quite easy, in my view, and it's okay even if you find that challenging because it's the first time you look at it. I would say that this whole section, most people should feel pretty confident about. This question here's a trick, by the way. You better look carefully at it. But it's using those same skills. Okay. And then you get into this section. Now, this section, you need to be very clearly read. You need to clearly read this. Make them possible, or make them easier to solve. You do not have to solve them. First thing, simple as. You just have to make them possible. You don't have to solve them. I will go through what I mean by make them possible. But if you are deciding that you want to push yourself and you already know your algorithm strategy for division, have a nudge. But you do not have to solve them. The only thing you have to do is make them possible. So I'll talk about how to do that. And then just at the bottom, I've got a multiplication problem, which is very tricky. Well, I don't think it's very tricky, but it probably would be very tricky for some of you. So again, that is a question that I am okay with you not doing if you're aiming low. Like if you're just aiming to be at, or, well, no, let's not use those words. This is a question for those people who want to push themselves. Okay, that's as simple as it is. It's not a question for everyone. It's a question for those people who want to push themselves. I would hope that that's nearly everybody in the group, but you know, what happens will happen. I also wanted to talk to you just quickly about last week's work. I haven't marked it yet. I will be beginning to mark it Monday night. So don't worry that you haven't got a comment. If you haven't got a comment yet, that's my Monday night's work. Yay. But it's good. It's good. What I have seen from people has been exceptional, and it was also what inspired me to use this AutoDraw program, because some people did it and it looked so much easier to read. But so let's do this. So let's talk about this practicing equal equations concept, because it's just a concept. It's just like every other concept. You just have to understand the idea behind it. Cool. Just checking that it's still live. Still good. Okay, so what I'm going to do is I'm going to start off just at the very basics. So right here I have a blank piece of paper, and I'm going to ask myself the question: how many ones fit into 10? Now I hope that you're like, Mr. B, are you kidding me? How many ones fit into 10? There's 10 of them. 10 lots of 1 fit into 10. Now this is the foundation of the problems that we're going to be working on, because of one thing and one thing only. We can all see that 10 ones fit into 10. But sometimes people get confused by things like this. Point ones into 1. Now the foundation of this system, this way of working it, is that if I change this one, I can change this one by the same amount. So as you know, point one, man, the decimal points are quite hard to do on this program. I might have to look at a different program. Point one, to make it 10 times bigger, all we have to do is move the decimal place. Very bizarre and to do on a device. I'll just delete that. So I move the decimal place to here. And then it's no longer 0.1, but it is 1.0. So if I move the decimal place from there to there, the number is 1.0. So that is multiplying it by 10. Now, if I take this problem, which was, terrible circling. If I take this problem and I do that process, I multiply this by 10, so I'm taking that and I'm putting it there, which makes it 1. This one is already 1.0. So if I want to multiply it by 10, I have to move the decimal point, yes. So I have to add a 0. So then it literally becomes a totally different problem, which is 1 into 10. Which of course is blindingly simple because it's 10. I hope you're all sitting there following my process. So the process that we're talking about is essentially moving the decimal place or multiplying stuff by 10 to make things easier, to make work easier. So let's have a look at, I've just got a message, sorry guys. Okay. To look at making life easier, we're going to multiply by 10. So let's have a look at a problem that is actually not hard, but at least takes a little bit of brain power. Cool. So we'll have a look at something similar to the first problem. No, not similar to the first problem. Similar to problem 7. Okay, so something similar to problem 7. What was it? 10. Oh, 0.1 into 10. Now you're thinking, well, that's, that might be a bit of a mind trick for you. But how we're using this strategy is we're going jump the decimal place so it no longer becomes 0.1. Oh no, Mr. B, come on. It's now no longer 0.1, it is 1.0. I wish I could figure out how to use a delete button. Oh, maybe this is the delete button. I might be able to do it now. Oh, excellent. So now it's no longer 0.1, but it's 1.0. Now I multiplied that by 10. So now I need to multiply this number by 10. And that leaves me with simply, how many ones fit into 100? Well, the answer to that, how many ones fit into 100? Well, how many ones fit into any number is that number. So the answer is 100. So I'll go through that one more time with another problem that's similar to that. Make this big, delete it all. Oh, I can delete right off the screen. How intriguing. Okay, here we go. Down here. So we're going to use another problem. We're going to go something along the lines of 0.0. Point 2 into, let's try it, make our lives a little harder. 1 0.5. 6 actually, let's make it not too, I don't want to get you too tricked in maths here. So that might be, you might be sitting there going, oh nuts, I can't figure that out. It's got complicated decimals. So your process, you're going to multiply this one by 10, which makes it, instead of 0.2, it makes it the supremely complex number, which is 2. Oh no, Mr. B, that's shocking. I'll have to find a different program to use because I am terrible at this one. Suggestions in the comments. Which makes it a supremely hard number, which is 2. And then we multiply this one by 10, which is just moving the decimal point. So if the decimal point was there, we'd be talking about 16. 2's into 16. How many groups of 2 do we fit into 16? So what you would do, if you didn't know that off the top of your head, which I know most of you will, but you'd go up your 2 times tables. It's not 2, it's not 4, it's not 6, it's not 8, it's not 10, it's not 12, it's not 14, it's 16. The answer would be supremely hard 8. Now the answer to 2's into 16 is 8. The answer to 0.2 into 1.6 is still 8. The answer is still the same, because if you're modifying both of them by the same amount, they are the same answer. Okay, so I'm just going to exit some of this stuff off and make the thing kind of look a bit tidier, because the backspace button's kind of my friend right at the moment. Oh, it's the first thing I got, which was a shoe. Excellent. Okay, so we've looked at what you have to do with this one. So this is making it, task 1 is all about actually doing them and solving them. And it's about gaining that understanding of how you can move the decimal place to make it simpler, and you have to solve them. Task 2 is kind of similar, except for I'm not requiring you to solve them. Do your best, but you don't have to solve them. You just have to make them more usable, more solvable. So let's go through and we'll have a look at some of these problems. So first sort of problem, 10's into 20 and into 0.23. If you look at that off the top of your head, you're like, oh, that's not a nice problem. I'm gonna change it a little bit so that you guys can't copy me. How many 0.25's into 10? Now, you could solve that many different ways, but the strategy that we're talking about and the strategy that the sort of answer that I want to see on this one is I'm going to jump this one twice. 1, 2, which gives me 25. How many 25's fit into? Now, I did have a decimal. There's no decimal point there, but I'm inventing one. I'm doing my double jump. How many 25's into 1,000? And you can see how many 25's into 1,000. Well, that's actually quite easy, because there's 4 on 100 and there's 10 groups of that, so it's 40. Yeah, it's just 40. So I'm not expecting you to answer them, but if you want to answer them, you can. This is all about making your life easier. So the minimum step for that problem would be showing me, oh, I'm going to do 25's into 1,000. All this is about is making your life easier. You do not have to solve these problems, because some of them may look quite tricky. That's what that's about. And the last question is a word problem. I'll read it out to you, and then I'm going to draw a picture of my make-believe car, which is kind of like my real car, so you can sort of get the idea behind it. One word problem to keep your mind in multiplication. So that's what I've titled it. And it's volume of a triangular prism is half base times height times depth. And volume of a rectangular prism is calculated by base times height times depth. Mr. B's car is a triangular prism at the front and a rectangular prism at the back. The car is 1.37 meters deep and 1.45 meters high. Find an estimate volume for the car, assuming the car is 4.3 meters long and the front third is a triangular prism. So what I'll do is I'll draw out what you can actually expect. So let's get rid of my terrible. As I said, any suggestions on drawing programs be appreciated. So, what we're looking at is the length of my car is going to be 4.3. meters. The first third, mystery distance, first third, that's a third, is a triangular prism. So that will go, and the back part is a rectangular prism. What you know about this thing is that Mr. B can't draw, and you also know that the depth, which is this part here, is 1.37, and the height, which is this part here, height, up and down, depth, height is 1.45. So that's the depth there, which is this part along there. It's also there as well. If I could draw it would help. And the height is this up and down part right here. And that's 1.45. The total length is 4.3. But a third of that is a triangular prism, which will affect your overall volume. And that's it for the week, guys. That's your giant problems for the week. Hope you enjoy it. Have fun.